In the last video, we talked about the movement of ions in and out of cardiac cells and how that causes contraction and creates electricity. What we're going to look at now are the players inside the heart that create and conduct that electricity. What we have listed over on the right are the 5 players. These guys conduct electricity. They don't contract. All the other cells, or most of the other cells in the heart, are the contractile cells. These guys just create the electricity, and as it moves throughout the heart, the electrical wave causes the contractile tissues that are touching it to contract. So let's see how this would work. The main player is the SA node, the sinoatrial node. It is found in the right atrium. It's this little purple dot up here. Its claim to fame is that it leaks potassium quicker than any other group of cells. That means it's going to fire off electricity. It's going to reset more quickly and fire off again quicker than anyone else. We also call this SA node the pacemaker. Put that right over here, pacemaker. So it is the quickest and the fastest potassium leaker. The electricity that it generates when it does its leaking and the sodium goes rushing in spreads down these little purple pathways, and everywhere it spreads it causes a wave of contraction out in the contractile tissues, so that would make the right atrium contract. The electricity comes across through a thing called Bachmann's bundle here, comes across into the left atrium and causes the left atrium to contract. The electricity ends up in this little purple part right here called the atrioventricular node, or the AV node. Because of this connective tissue plate, the electricity can't go directly into the ventricles. The only pathway a healthy heart has to send electricity to the ventricles is through the AV node. So the electricity comes into the AV node. The AV node gathers all the electricity. It holds on to it for a couple of milliseconds, and then it sends it down the bundle of His, which is this part right here, the transition between the atria and the ventricles. The bundle of His breaks into 2 parts, and you have the left and the right bundle branches, and beneath that we just call those Purkinje fibers. In truth, everything below the AV node is Purkinje fiber. They all look the same, and the thing about the Purkinje fiber system is that it conducts electricity very, very fast. It's often referred to as the Autobahn because it conducts electricity so quickly. So the electricity would move from this point to this point and this point and this point in 0.01 seconds. Essentially, it is in both places at the same time, and as it travels down and up, it's causing the contractile tissues to contract. Same thing over here. The contractile tissues contract.